The railway network of India is the biggest in Asian continent and also the most complicated network in this world. There are so many different types of trains such as local, fast, super fast and passengers goods between the villages and cities. It acts as the main platform for transportation and only a single route which connects all the places, all the trains that goes in the same line. Although the timetable is perfect, it's not at all possible to maintain it, and that's why the train accidents so happens as a more usual. To overcome this kind of errors in signaling, we concluded a train engine which is having a nature of preventing all the accidents in the transportation. By overcoming the problem of manual optimization of train engine, we are going to implement the automatic intelligent train engine in the track, which is satisfied two conditions such as red light detection and autocross detection. According to this description, which prevents those accidents by automatically controlling the speed within the engine accident-prone areas. The project undertaken for the TA Analog Design Contest of Indian Universities 2010.
Before getting into the project, I have to give some small explanation about the circuits. This is the transmitter side of signal poles, and this is the receiver side, which is present in the master train, and the indicator which indicates the function going on. Here is the signal pole, which is green light. When it stands to red, the RF module in the transmitter side which transmit the RF frequencies, and it will be received by the receiver present in the master train. Here is the RF module. Whenever the transmitter from this it transmits the RF transmission, and it's received by the receiver here, and the signal is passed through to the microcontroller, and the microcontroller which transmit the signal to the board, and this is denoted by this LED. Whenever the signal is changed to green, the LED will be switched off because there is no RF transmission. When it again changed to red, the LED get to be glowed. By varying for using different frequencies, we adapted to make different kinds of RF modules. It's a 27 MHz RF transmitter, and it will be received by the RF receiver of same 27 MHz. Here is the another train, which is mainly responsible for detecting the autocross detection, which is present in both the trains. I have to fix these circuits in another train. For autocross detection, we implemented two different trains in the same track. Here is one module, and the train is here. Here is the train we are going to implement this autocross detection, and this is the master train circuit, and this is another train. When both the trains are transmitted the RF signals, here the signal is transmitted and it's received by the receiver here, and here is the signal of transmission, and it will be received by the. While going for this condition, there is a great impact is that for assigning the different signals for parallel tracks. By assigning this, we have included a small technique is that
the IR technology is used in this area. The IR transmitter in the track which transmits the signal, it's received by the receiver in the engine. When it receives, the track element set to be 1, otherwise 0. So while going for the parallel track condition, the track can be varied. According to this, the IR technology is used.
Here I had fabricated all the component in this train. Here's the two different model trains and a RF transmitter as considered as a signal pole. These two trains are mainly based for the parallel tracking system. While we are going for parallel tracks, we have to differentiate two different codes for transmission. By varying this model can be executed. And I had fabricated the total circuits in a single garage, and I fabricated the two different 9 volt and 3 volt batteries in different garage for smoothing the load for this model train. Here's the train kit. Now I am going to switch on the train. And the train is getting to be run. Here is the green signal, so the train is moving on its way. When I change it to red signal, and here is the train stops because it's receiving the signal from the RF transmitter. This is the condition for this train. Now we can see the second condition. Whenever the train is transmitted and it's received by the receiver and the train get to be stopped, it indicated by this LED. And here also the same condition. For IR condition, this LED glows, and for stopping condition, this LED glows. So which represent that the transmission has successfully takes place. And this is the main function of our project. By adopting this in railway systems, we can surely defend the accidents going to be happen.
Our special thanks to Texas for giving this great and wonderful opportunity for us to show our talents.